Hi guys, nice to see you back. We continue with the 16 segment displays because the subject is not as easy as it looks. The first confusing thing is actually the names of the segments. Is because you know the 7 segments, that's easy, but when they are 16, I'm going to use the model I have because I consider it very well organized. And here it is. You remember the order we established for the 7 segments. The one in the top is A. So this is A. But right now is made of 2 half segments each. And this is why they are called A1 and A2. Both of them, they make, if you use it as a 7 segments, they make the A exactly like here in the top. Okay? So then we go clockwise. So it's B, C. When you have D, you have the same as for the A. This is D. It is made of 2 half segments, D1, D2. E, F, and G in the middle is similar. So G in the middle is similar, made of 2 half segments. But then, what do we do with the other 1, 2, 3, 4, 5, 6 segments? I chose that model on purpose because on that model here, once we finished with the 7 segments, we go again clockwise. So we start from here, H. Don't like the letter I because the letter I is a bit confusing. Next after I is J, then is K, L, M, and N. So that's how we make the 16 segments. And surely if we want to use the decimal point, it's separated right here. So if you count 16 segments plus this one, it's gonna make practically 17. And on some digits, you're going to find the second decimal point located right here. And if it is the case, this one is gonna be decimal point 1 and decimal point 2. So 16 segments plus 2 other diodes here, 18. Plus remember 2 pins for the common is making 20. So that package has 20 terminals around. I have here 2 samples, this one here and this one here. As you can see, they look identical. However, if you turn it on its back, this one here is a common anode and this one is a common cathode. You can even see that the circuit inside, because it's completely sealed, is the resin here. Okay? The circuit underneath is different. They are not made by the same company. However, one is common anode, the other one is common cathode. Okay? Let's stay with this one now. The pins. If you take a look at the pins, you have to hold it with the decimal point if there is only one decimal point to the bottom right. And the pin number 1 is right here on my left. So when we turn it upside down, the pin number 1 is gonna come here. So you count 1, 2, 3, and so on up to 10. And then 11, 12, 13, and so on up to 19. The pin 20 is missing. Why is this missing? Because the pin 20 was reserved for the second decimal point here, which is missing on this one. So the standard package has 20 pins, but the pin 20 is missing if the second decimal point is missing. And if I'm picking up the extract from the specifications, where the manufacturer gives us all the pin numbers, here, if you can see, all the cathodes are together. So this is common cathode version. And here all the anodes are together. This is the common anode version. But the pin numbers are the same, and on both they say 20, no connect. Actually, they wanted to say pin 20 was not connected. 20, not connected, okay? So this is why the pin 20 is missing, not because it's broken, but because they didn't put it there. Let's go further. So that's the important part to understand what is the order of the segments, because when you want to control them, you have to know exactly what segment should be lit, okay? The second thing about it is also taken from the specifications of the manufacturer. Remember what we discussed some time ago, 7-segment displays, 0.3 inches, 0.5 inches or 0.56, 0.8 inches, 1 inch, 1.5 inches, up to here, they may have one LED per segment, actually up to 0.8 inches. They have only one LED per segment. But here, if you can take a look, each segment or half segment, so if it is a segment, I'm talking about this one here, like this is B, or a half segment, like here, like G1, G2, each of them has inside 2 LEDs. For that reason, another problem we're going to have with the 16-segment displays is when we try to measure them. Because if you try to measure them, you're going to find out with the multimeter that's practically not possible to measure them, because the multimeter position for the diodes was made practically to measure rectifiers, and for the LEDs we measured them some time ago, and when there are 2 of them in series and you want to measure, then you're going to find out that the meter does not indicate anything about that. So on this kind of 16-segment display, the only segment, let's call it a segment, we can measure is here, where you see only one diode, because this is the decimal point. That's the only one you're going to be able to measure with the multimeter, but the others you won't. For that reason, you cannot measure with the multimeter, you have to use the voltage to measure it. But now you're going to have another problem, because the size of this display, it makes it very difficult to plug anywhere here. So anytime you try to plug it anywhere, there is no room remaining to take measurements around the terminals, okay? So anywhere you try to move it, anywhere, you're going to have a problem. The only way you can overcome this problem is if you take 2 separate breadboards, not both of them assembled here for a double, but 2 separated ones, so you can keep them at a distance, and then you can plug this one half on one breadboard and half on the other breadboard, so then you can try to measure. And this is why I preferred to build a tester, okay? This is going to be our tester. We're going to build it together next time. So when you take a look from the bottom, you give me a second. I have here the magnified picture of it. Don't worry, you're going to find all these documents in a folder. I'm going to make a special folder on Google Drive called 16-segment display. And here, this one, it's exactly the wiring, which is right here. And if you take a look on the drawing, you're going to find out that, let's say for the pin 10 is the decimal point DP. On the pin 1 is the common anode. Why there is no wiring here? Because the same as this one, you're going to find on the other side, on the diagonal, on the pin 11, common anode, and I'm going to use this one. So you can do one such tester, and you're going to be able to test either the common anode, like this one here, or the common cathode as well, okay? So we're going to test them both, don't worry about that. So this one here, you're going to find before we're going to be able to build it, because at the end of the little video today, I'm going to tell you a couple of things about the parts you would need to build it, okay? So right now, because we're here already, let's say we want to see the segments. We put the power off, power on. At this moment, if it is a common anode display, or sorry, this is a common cathode display, you're going to see the decimal point. But then here is just to identify what we discussed first, the order of the segments. So I made a circuit we're going to discuss in another video, just to pick up the segments in that particular order to identify them one by one and going clockwise. So this one you see lit right now is A1. You do one more step, you have A2. Then you have what you know, B and C. This is D2, this is D1, E, F, and now G1, G2. And then after this, we're going to go also clockwise, H, J, K, L, M, N. At the end is the decimal point. And then we can restart, okay? You want to check them automatically, not a problem. You can adjust obviously the speed because you may want it to be much slower to be able to watch when you verify if the segments are in good condition, okay? Because if you don't use them properly in projects, obviously you may burn one of the segments, so you want to know exactly which of them burned to identify the reason, okay? Okay? So that's how you do it, okay? So this one here is the tester already built, okay? But right now, let's see how can we identify the segments if we don't know, we don't have a generator already made to send signals to the tester, okay? So then, I'm going to disconnect it from here and connected it bare as it is in on another empty board. Be careful because what you have to respect is the little cobbler here. And by the way, when I'm going to describe this one, is a extension board for a Raspberry, but this is the Raspberry versions A and B, 26 pins, the flat cable, and the GPIO, the old version 26 pins. Surely we can use the newer one, but the newer one is 40 pin, is too bulky, too big, okay? So before we talk more about the construction, let's find out. I said this is a common cathode, so here is the common. Because I say it's common cathode, I'm going to plug this one to the negative. So then remember that anytime you power an LED, you energize an LED, it has to have a limiting resistor. So there is a 100 ohm limiting resistor right here with a piece of wire. So then let's say I'm going to use the chart I've built. This one here represents the 26 pin connector coming from GPIO, this one here. And this part is representing what's coming, the part of the cobbler coming on the breadboard. So here, the signals, I put them in dark gray. The signals for the Raspberry are not relevant right now. They are just here to identify each terminal because they are printed on the cobbler. But what's important is I identified for you here in advance to save your time what's coming on each of these contacts, which of the segments of the 16 display, okay? So here, for instance, if I want to identify just the decimal point is right here, is 1, 2, 3, the fourth one from the bottom on this side, 1, 2, 3, 4, okay? So in order to see it, we're going to put the power off, is off, and we're going to move the supply from the generator over here. So when we do, and we put it on, here we see the decimal point, okay? Sorry, that's how you see the decimal point. Let's say I want to identify the segment H. The segment H, remember the segment H is right here, okay? So what am I doing? I'm looking here, where is the segment H? Oh, it's here. This from the bottom is 1, 2, 3, 4, the fifth one. So on the other side, 1, 2, 3, 4, 5. You see this? That's the segment H. Let's say I want to identify now A1. A1 is the fourth one on the other side from the top. the fourth one on the other side from the top. This is A1, because A1 is right here. Let's say I want to identify L. L is located right here. So what am I going to do? If I want the L, I'm taking a look around, and it's the second one from the top, like that. So second one from the top is here. Here is my L, okay? Last one to take as example here. Let's say I want to identify the J. The J is right here in the middle, in the top, okay? So I take a look around. J is the third one from the top, so it's just the next one. Here it is. That's J, okay? So that's what you do when you want to verify it manually. Because we're here, take a look, we put the power off, and we try now to identify the segments with the multimeter. We put it on diode measurement. Right now is on diode measurement. And we have the common. The common is connected already to the negative, the power being off. So right now, if I want the decimal point, we take a look here, and the decimal point is the fourth one from the bottom. 1, 2, 3, 4, right here. Okay? So, sorry for that. 1, 2, 3, 4, right here. So you can see the decimal point is going on. So you may think, oh, that's okay, that's so far so good. Let's identify another one. Next, in the top of the decimal point, in the top of the decimal point is the C. Segment C is right here. But if you try to do it, okay, in the top of the decimal point, the fifth, 1, 2, 3, 4, remember this is the decimal point. The next one, you try to do it and you don't see it. Why don't you see it? Simply because the multimeter is not capable to measure such a segment. There are two LEDs in series inside the segment, and the meter doesn't know what to do. So it doesn't matter what meter you have, okay? The meter is not capable to show you the light because there are two LEDs in series. And if the digit is bigger than this one, bigger the problem is because they have more and more LEDs per segment, okay? But starting with 1 inch size, 1 inch, 1.5, 2.3, and so on, all of them, they have at least 2 LEDs per segment like this one. So again, you are capable to identify the decimal point for a simple reason. That's the only thing inside having only one LED. Any other you can try anywhere you want. It's impossible to see anything. I'm measuring them one by one right now, and it's impossible to see with the meter. This is why the only way you can identify is to use the voltage. But again, when you use the voltage, please don't forget about the limiting resistor. Okay? So if I remove this one now, okay? I remove this one. It was a common cathode, and I put instead a common anode. I pick it up from here. So I put a common anode now. Okay, I hope I plugged it right. We're going to do the same. We pick up our meter. And because it's a common anode, I'm going to pick up the common from here, and I'm going to place it on the other line. This is going to be the common right now. And I'm going to move my resistor to the ground, to the negative. And then, even if I don't need the resistor now, I'm going to check it with the voltage soon. I'm going to try again. So, take a look. With the black of my meter, which is now representing the negative, I'm touching the fourth pin here, is the decimal point. But the other ones, I'm checking, I'm not capable to do anything, okay? So the meter is practically useless. It doesn't matter how good it is, okay? Now, let's try with the voltage. We plug the voltage back, right here. We put it on, and then having the resistor connected to the ground, we connect it one by one. Let's find out what we know. This one we know, but now take a look. All the segments can be found. Just one more example. If I want, let's say, to find the segment M, the segment M is the straight line in the bottom, is gonna be found. The third one from the bottom, right here. Third one from the bottom, right here. This is going to be the segment M. And that's how we find it manually, okay? See? So, fancy thing. If we connect it back on our tester, okay? Right now, right here it is. Okay. Because this is a common anode, I'm going to put the anode to the positive. And when I'm going to move the power, on the other side, let's put it first manually to see something interesting happening. You see, this time, because it's a common anode, all the segments are lit, with the exception of the decimal point. When I'm going to press the button, take a look what funny thing is happening. The segment A1 goes off, is the only one going off. A2 goes off, B goes off, C goes off. Because I go clockwise, is D2, D1, E, F, G1, G2, and then I start from here, H, J, K, L, M, and N. And then the decimal point, okay? So that's another way to check. This is when the segments are making a common anode. But I can check them anyway. See, that's our tester we're gonna make, okay? And now, just to clarify before we clarify the confusion, I want to mention just another point. What's very interesting about this kind of displays is that unlike the 7 segment, the way the segments are arranged, they make the display symmetrical. In other words, if I shift it 180 degrees, in other words, upside down, it's still going to have the same order of the segments, excepting the decimal point, which was here, it moved over here. This may be very useful, for instance, if you want to build a clock. And I just lit both decimal points right here. One from the display, which is arranged normally, like that. But then, for the next one, only for the next one, I put it upside down, and I can still see a 0, okay? So, I put them on purpose because I actually didn't need them right now, but just for you to see, if you take a look at the 4, 1, 2, 3, 4, the 1, 2, 3, 4 displays, the first, the second, and the fourth, all the three, they have the decimal point on the bottom right. But the third, it has the decimal point on the top left. It's not another kind of display, it's the same. I just shift it upside down because I wanted the 2 dots to be used. So that's what you can do, and it is very nice about this kind of display. So right now, we're gonna come on these drawings surely next time. We're going to move to a computer to see how confusing that information may become, even if you don't deserve that, but that's the information you find on the internet. And what kind of parts may you need to do the project. Let's move over there. Okay then, so here we are. I typed here on Google 16 segment display and I asked for pictures. So then probably the first link you're going to get is on Wikipedia. I picked up this one and I magnified it, okay? So when I magnified, I've got that picture. So now take a look. A1, A2, B, C, D1, D2, E, F, G1, G2, everything is fine because this is like mimicking the 7-segment display. But then, take a look what happens. On this kind of display they describe, the segment here on the top is H, exactly like mine. But the next, they use the letter I, and they use the letter J. And in the bottom, on the right, they use M, and then they used L, and then they use K instead of N. It's completely different in the middle. So of course, if you don't know the right order of the segments, you can easily be wrong, okay? Let's go further. On the same page with pictures, I find this one. And from this one here, if I magnify, take a look what order I find. I don't discuss about the 7 segments because they're the same. But then take a look here. Instead of having the H like mine, they have J, and then they have H, and then they have K. And in the bottom here, they have L like mine, but then they have I, and then they have M, okay? So it doesn't look like mine, but it doesn't look like the previous one either, okay? It doesn't look like the previous one either, okay? And if you go on this one, it's on the same page. Take a look here. I suspect that for this one, they put here right away the numbers of the terminal numbers of the package, okay? But they didn't name the segments. They just told you this half segment, whatever you call it, what pin number is. This one here, 14. They don't give a name to the segment, they only tell you the pin number. So the pin numbers are going to be very different from the ones I have. So this is just to mention to you, please be very careful because the 16 segment displays are not that easy as you think they are, okay? Anyway, once I warn you about this, let's go a bit for the parts. Easiest thing, you're going to need a board, a prototyping board or a proto board. The size of it, I'm going to give it to you in metric because even on the North American continent, if you go on Amazon, you're going to find it described in both. So metric is not that difficult actually. It's 8 by 12 centimeter. So if I'm going right here on one of my, let's just find the page I put aside, my favorite site to order stuff, abra.com, abraelectronics.com. Remember, they have a Canadian and they have an American site as well. 8 by 12 centimeter. So it's very easy to find. This is when you only want to buy one because on Amazon you're going to find a batch containing several of them. But if you only want to buy one, you can go here. There's one thing you need. What is more difficult is about a very particular component I'm going to show you right now. The component is this one. What is particular about it? If you take a look at the standard connector, I'm going to put it in the same position. This is bigger, but doesn't matter. The principle is the same. If you put it in that position here and you take a look in the back, the pitch, meaning the distance between the two rows here, is 2.54 millimeter or 0.1 inches, exactly like the distance between two pins. But this one, if you want to plug it on a breadboard, you cannot put it along the slot, because along the slot you need 0.3 inches or approximately 7.5 millimeter. So this one cannot be plugged on the breadboard on separate rows along the slot. This is why you need a kind of an adapter like this. Unfortunately, I couldn't find it yet because it's out of stock. I'm going to get it later, so I had to improvise something else. But the best thing you can get is this thing here. This, as you can see in the bottom, it has 0.3 inches, and in the top it has 0.1 inches. So that's an adapter going directly on the breadboard. And I have two versions here to show. One is on a Canadian site called qkits.com, and they call this IDC ribbon. This kind of flat cable is called IDC. Okay, so it can have like this one here, it has 16 wires. This one here, it has 26. Okay, but both of them are called IDC cables, and these are IDC connectors. And that connector here, if you take a look around it, where I put my finger, it has a notch, and the notch has to be aligned with the opening here. Okay, and that's how it's going to enter. But when you remove the cable, the pitch is exactly 0.1 inches or 2.5 millimeter, exactly like here. And on the other side, you have 0.3 inches, so you can plug it on a breadboard. That's a key component you need for a lot of projects, not only for this one, but you need the one with 20 terminals. So right now, as you can see here, is out of stock. I'm sorry for that. When they're gonna get it back, I'm gonna order as well. However, if I go on my favorite site, abraelectronics.com, what am I going to find? It's another one. They call this IDC breadboard helper. I consider the word adapter was just good, but that's how they call it. This is 2x16 pin and is made by Adafruit. You won't find the 2x10 to make 20. It doesn't matter. If you order this one, the last 1, 2, 3, 4, 5, 6 pins on each side, you can cut them off. You can cut them off. So then you can plug clearly the 20 pin cable across it. So this is going to be a good thing to do, and this is very appropriate. Okay. However, if I'm talking about the cables, cables can be found everywhere on Amazon, for instance. For me, I'm going to describe it in another video. I would prefer this one because I'm going to show you exactly this kind of tool, how to use it to make your own cable, and you won't depend on separate cables anymore, because you can build it yourself. But before you're able to build yourself, at least you can find some. For instance, this pack here, it's a 20 pin connector with IDC cable, of course. The pitch is good, 2.54 millimeter, and it has 180 millimeter, which is 18 centimeter. It's very good for this kind of project, okay? And it's not expensive, okay? So the cable is not a problem. However, I didn't have this cable myself, so I had to improvise. So then what I found was it was an adapter. It's called an extension board. It's called an extension board for the Raspberry Pi, a cobbler. This, what you see here, it looks like a good version here, because clearly you can plug this one on any breadboard. And here is a standard connector, but this is too big, it's 40 pins, it's way too big. So this way, this is the cable for it. The flat cable, the IDC cable, it's too wide, okay? I don't like it, it's too wide, okay? You're going to need, this is what I improvised on my board because I didn't have the 20 pin one. I improvised with this one, which is for the older Raspberry. And this is for the Raspberry A and B, sorry, having 26 pins, okay? 26 pins, because from the 26 pins, you have the plus and the minus. You can use one of them for the common. And there are exactly 17 pins remaining, 16 for the segments and 1 for the decimal point. So that's a good one to use, okay? So this one here, plus the cobbler, which is similar to this one, but only with 26 pins, okay? Yeah, that's okay. This was the printed board. They show you here another thing they have, which is interesting. On Abra Electronics, they have a kind of kit where they give you a little printed board and they give you an adapter with it, which is 26 pin, exactly like the one in size, exactly like the one for the Raspberry A or B. So this one is also good to use, and you have here the code if you want to order from Abra. Okay, so please be prepared with these kind of things, because next time we're gonna build it together, and we're gonna discuss more about checking or testing the 16 segment display. Thank you very much. See you next time. Bye bye.